Hello, Legacy students, Miss Marsh here. Today we're going to look at linear or not. So basically linear and nonlinear functions. Some stuff you're going to want to have on you. Notebook, pencil, those graph paper squares that I gave you in class today, and then also a calculator. Your learning goal for this particular video: I can identify a linear function when given a graph or table. So first, some vocabulary. A linear function is a function, surprise, surprise, whose change in y's and change in x values is constant. So basically it goes up by a constant amount. Every time that I go up by 2 in the x's, I go up by 3 in the y's. Another way to pick out a linear function is its graph is a line. Okay, so that's one way to pick it out. What about a nonlinear function? Well, a nonlinear function is still a function, but its change in x and y are not constant. So basically it doesn't go up by the same amount each time. And if you graph them, they don't form a line. It's going to have a curve in it. Okay, so let's actually try a few examples here. What about this graph? I need to tell by the table, I want to graph it, see if its function is linear or nonlinear. So the function, or my ordered pair, is 0, 1. So 0, 1, that would be my ordered pair right there. 2, 3, right there, because remember, you graph x's first and then y's. 3, 1, 2, 3, 1, 2, 3, 4. And then 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So now I'm going to connect my dots here to the best of my ability. You would have a lot better idea. There we go. Now, is that a linear function? It's a line, right? So I know that this guy is a linear, linear function, because he goes into a straight line. When I graph his ordered pairs, it is a straight line. Let's see if this function's linear or nonlinear. So I got 1, 4, so up over 1, up 4, 1, 2, 3, 4, over 2, up 1, 3, 0, and 1, 6, 1, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1. So it's going to be a graph that looks something like this, right? Is that linear? I'm pretty sure not. That is not a straight line. So this is a non-linear function. Let's see though. We don't want to always have to use a graph, do we? That's going to kind of stink to always have to have graph paper. So let's see if we can figure it out via a table. So I'm going to write my ordered pairs here in table form. So I got 210, 420, 525, 735, and 945. Now, let's see how much my x values go up by. So this goes up by 2, this goes up by 1, this goes up by 2, and this goes up by 2. These go up, my y's, by 10, this one goes up by only 5, this goes up by 10, and this goes up by 10. Now, you're probably saying it's not linear because the x and y's don't go up by a constant amount. Well, they kind of do. What if we would just not even think about this part right here? Notice that each time I go up by 2, I am only going up by 10 on my y's. Same thing happens here and here. This is because we're only going up by 1. Every time I go up by 1, I would only go up by 5, which makes sense, right? If I go up by 2 on the x's and I go up by 10 on the y, if I only go up by 1 on the x's, I should only go up by 5, right? Because 10 divided by 2 is 5. So this is actually a linear function because I'm going up by 10 on the y as I go up by 2 on the x. Let's try the last problem here. What about this one? So let's make our table so we can be able to see it here. 0, 0, 1, 1, 2, 8, 3, and 27, 4, and 64. So it looks like my x's, each time I go up, it looks like I'm going up by only 1, right? What about this side? Well, here I go up by 1. Here I go up by 7. Here I go up by 19. Here I go up by 37. That's not linear. Not going up by the same amount each time, by any means, right? So this guy is non-linear. And that's the end of this video. See you later, Sabers.